Welcome back to our last video of Chapter 9, ladies and gentlemen. Today we will be talking about Type 2 error and the power of a test. We are going back to Section 9.2. And by the end of this lesson, you will be able to interpret the power of a significance test and describe what factors affect the power of a test. At the end of this lesson, I want you to try these problems. Let's begin. All right, as I said, we are going back to Section 9.2. We are going to discuss types of error and power a little bit more. Specifically, we are looking at Section 9.2, Day 3, Type 2 errors and power. All right, now you can read much of this information on pages 612 to 617. And we're going to start out with what is the power of a test and how is power related to the probability of a Type 2 error. Now, the definition is that the power of a test is the probability that the test will find convincing evidence for the alternative hypothesis when a specific alternative value of the parameter is true. Now, what does this mean? It means that the power of the test, or the power is the probability of avoiding a Type 2 error, basically of rejecting your null hypothesis and finding convincing evidence of our alternative when we really should and when the alternative really is true. So it's the complement of the probability of a Type 2 error. That means that the power of a test to detect a specific alternative parameter is related to the probability of a Type 2 error for that alternative. Now, in order to truly calculate these and not just describe them, you need to know what that alternative value is, because both of these probabilities will change depending on how far the alternative parameter is from the null parameter. All right, so the power of a test to be able to detect that specific alternative parameter value is equal to 1 minus the probability of a Type 2 error, and likewise, the probability of a Type 2 error is equal to 1 minus the power. So the greater the power, the less likely you are to make a Type 2 error, and the more likely you are to make a Type 2 error, the less power you have. All right, let's go ahead and take a look at our example. All right, a drug manufacturer has developed a new cholesterol-reducing medication that they think is better than its current drug. To test it, they recruit 100 volunteers and randomly assign half to the new drug and half to the old drug. When the experiment is over, they will conduct a significance test to determine if there is convincing evidence that the new drug is better than the current drug. Now, for letter A, we want to describe a Type 1 and Type 2 error in this context. All right, so Type 1 error, the drug manufacturer finds convincing evidence that the new drug is better than the old drug when it is not. Remember, Type 1 is always finding convincing evidence, but it's that time that you find convincing evidence when the alternative is not actually true. Now, the other type of error that we can make is failing to find convincing evidence. And if it's an error, it means that our failure to find convincing evidence is the wrong answer. It's correct for our data, but it doesn't match reality. So Type 2 error, the drug manufacturer does not find convincing evidence that the new drug is better than the old drug when it actually is. It could just mean that the difference in efficacy between the two drugs is so small that it's very difficult to detect, meaning that the power isn't very strong. We could have had too few volunteers, so our sample size might have been too small for us to actually be able to determine whether or not there is convincing evidence. Sometimes we need to raise our significance level depending on how different we need the efficacy to actually be. Sometimes you only need a few points to actually make a big difference in the long run. It really depends on what you're trying to measure as to how big the difference really needs to be, which is why we do all this based on probability. Whether or not something is a large or small difference is relative to the measurement being taken. Right, now, describe the power of the test in this context. So the power of the test is the complement of that Type 2 error. So Type 2 was a drug manufacturer did not find convincing evidence that the new drug is better than the old drug when it is. So the power of the test is the probability that the drug manufacturer finds convincing evidence that the drug is better than the old drug when it actually is. All right, so the reality is that the new drug is better. Type 2 error would be failing to be able to make that conclusion, while the power of a test is the probability that we are able to make that conclusion. Now, keep in mind that this is always based on a specific alternative parameter. The more different the alternative parameter is from the null parameter, the better the probability that you'll actually be able to detect that difference. right? So this is our description of this. Now notice it said describe, it did not say calculate. Unless you know what the alternative parameter is, you have no way of calculating this. All right, now finally, how can the manufacturer increase the power of the test? And in general, what factors affect power? Well, the factors that affect power are the same ones that affect your type 1 and type 2 errors and how variable your data is going to be. So the power of a significance test to detect an alternative value of a parameter when the null hypothesis is false and the alternative is true is based on a random sample of size n and significance level of alpha. And this power is going to be larger when the sample size n is larger, because a larger sample size decreases variability by decreasing the standard deviation of the distributions that we are working with, which means that you can detect a more minute difference between parameter values when you have a larger sample size and thus less variability. The significance level alpha is larger. If you make it easier to reject your null hypothesis, you are less likely to fail to reject it when you really do need to reject it. Now, it also means that you are more likely to reject it falsely, so you're increasing that type 1 error. But as long as you're okay with that, then you can increase your significance level. Right? And these two are the main ones that the manufacturer could do. They could have more test subjects. They could double, triple, quadruple the number of volunteers that they're using in their experiment. And they could also increase their significance level. Now, increasing significance level runs the risk that when the experiment is replicated by a third party, or if they try to replicate it again elsewhere, that they won't achieve the same results. So you have to be careful with increasing that significance level. Now, the null and alternative parameter values are further apart. This isn't necessarily something that we can affect. However, what you can look at is, based on a specific alternative parameter, what's the likelihood that you'll actually find your results, and determining how different you really want them to be, and then adjusting your sample size accordingly. All right, so all of these things are good things to take into account in the planning stage as well. All right, now go ahead and try these two problems, and I'll see you in class.